Okay, it seems that I missed the acceleration rate for acceleration factor for this equation. So using this formula here, acceleration value is 1 minus alpha, which alpha here is considered as 1.6, so 1 minus 1.6 is a minus 0.6. The last value plus alpha with the current value. Let's consider what should we do. The last value, so I said 0.6, which coming as a 1 minus 1.6. By previous value, the voltage it was 1 with the angle of 0, iteration 0, plus 1.6 times 0.92, 0.92 plus minus 0.1 J. So this value after calculation is equal 0.872, 0.872 minus 0.16 J. So the new value must replace by here. And let's see the new value calculation. I have minus 10 plus 20i times minus 1 minus 2.8 plus 0.6i divided by 0.872 minus 0.16i parenthesis. Okay. Divided by 10 minus 20i. So the value here is changed to 0.9316 minus 0.1272. Okay, so this one again need to be accelerated in the same way. So V2 iteration 2, which is accelerate the convergence rate, is minus 0.6 in the same way. Our previous value, which is accelerated previous value, which is 0.872 minus 0.16 J, correct? Plus 1.6 new value 0.9316 minus 0.1272. So the value here is times 1.6, correct? Yes, minus 0.6, 0.872 minus 0.16i. Okay, so the value reached to 0.9673674 minus 0.1076 or 76J. Then again, you can replace it by here and calculate this value. So this is the way you can accelerate the value of convergence. Sometimes this one, the acceleration rate for the small system with 2-3 buses is not working very well, but the efficiency of that one is proof for a big system with lots of buses around 300. Okay, so part B said after several iterations, assume this is the voltage of the bus 0.9 minus 1.1 J. Determine S1 and the real and reactive power losses of the line. So how we should calculate that one? For that purpose, part B, the best is we find out the current here. how we can find out the current here? We know the current between bus 1 to bus 2 is equal the voltage of bus 1, which coming from the first value, minus the voltage of bus 2, which is from the second indices, times y12, correct? And then you can find out what is the voltage. Right now, the voltage of bus 1, the voltage of bus 1 is 1 with the angle of 0, which is for the slack bus, correct? And voltage of bus 2 right now is given to us. And y over, okay, this is something issue. Y 2. This is not from Y bus. This is 1 over impedance between bus 1 and 2 without any minus. Don't forget. This one, in the case of calculation, no need to add any minus. So you can see 0.02 plus 0.04 J, which directly coming from this value of transmission line, must be considered here. So then the current between bus y and 1 and 2 is 3 minus 1J. Then what is the S value? S1, I think you can remember. It's V1 I1 to 2 conjugate, correct? And then S2 can be calculated in the way of V2, sorry, this is S1 to 2, this is S2 to 1. So this is S1 to 2, this is 2 to 1. I, oops, I 2 to 1 conjugate. Just look carefully here. Here is I12, and here we calculate I12. So this value is I12. The conjugate value here is 3 plus 1J, correct? So for this one, and here is I21. I21 is equal minus I12, okay? So minus I12 become minus 3 plus J. Then we need a conjugate for that one. So become minus 3 minus J times V2. Since V2 is 0.9 minus 0.1 J. And this one is times V1, which is 1 with the angle of 0, which is only 1. Then you can see S12 and S21 is calculated. Then the losses is S12 minus S21 or S12 plus S21. Okay, since we changed the direction, so just add up these two value and you can find out the losses. This value presented in per unit. If you want to convert it to real value, you should times it by 100 megavolt amps. So the value is 20 plus 40 J. This is megawatt. This is megavolt amp reactive. So this is the second part of second question. Okay, next one, which is the power system. Uh, it's this power system, as you can see, three buses. Bus 1 is a slack bus, bus 2 is a PQ bus, and bus 3 is a PV bus. So for bus 1, we know the voltage is given as 1.025 is the angle of 0. For the bus 2, we can see the P plus JQ, which are load. Don't forget, as you can see here, minus 4 minus 2J, since the per unit value, the S base is given as 100. And finally, here we have the PV bus, which is the P given to you as a 300, so 300 positive, and the voltage, absolute of voltage or magnitude of voltage is given as a 1.03. So the only things you need to calculate is the angle, okay? For the first round, you can assume it's 0. So for this one, and for this one, I think we should consider assume value for the first round iteration 0, 1 with the angle of 0. What should we do? It said this is the value. Okay, okay. 400, 200 taken for the bus 2. This is the base. The reactance of the line is given to you and susceptance is neglected. Find out the voltage of bus 2. No, the voltage of bus 2 for the initial V2 is 1 with the angle of 0, as you can see, and bus 3 also 1.03 with the angle of 0. Keeping V3 as 1.03, determine the V2 and V3. The magnitude of V3 for sure is no, is 1 point equal 1.03. The only things we have to determine is the angle, but for V2, for sure we need the V2 and the angle of delta 2. We don't know it, none of this. Okay. So what is the first action we should do? We have to construct the Y bus. So how we should construct the Y bus? Of course, you know. So the value of the Y bus can be found here, Y11, which is here, is connected to 0.05 and 0.025, which is minus 60. Then between 1 and 2 is 0.025, which is 40. Since we need a minus here, become minus 40 times minus 40, and the other one is 20, and the others calculated on the same way. So minus 80, minus 60, and this is the Y bus. I think we missed the J by here. You need to consider J by here. P2, which is here, P2 is minus 4 and Q2 is minus 2J, and P3 is positive, as you can see here, positive 3. Again, construction of the construction of the voltage equation based on the Gauss-Seidel is coming at the voltage of bus 2 in the first iteration is 1 over Y22, which is this one, you can see here. P2, P minus JQ, or in the simple way is S conjugate, so you construct the S minus 4 minus 2J, and then conjugated become minus 4 plus 2J over this is V2 in the zero iteration, as you can see is given by here, is this value 1 with the angle of 0, and then we have a sigma. We should consider bus 2 is considered to which bus. So bus 2 is considered to connected to bus 1 and connected to bus 3. So become y1 2 1 or 1 2 v1 plus y 2 3 v3. You have to calculate this one. So y12 is y12, y23, y23. Okay, the j also, don't forget there is a j for each of these. V1, since it's a slack bus, always is this value, and V3 for the first iteration means zero iteration, sorry, for the zero iteration is given as a 1.03. So we replace this value in the equation, as you can see, and we reach the new value. Right now, we have the same as the previous example. We have to use the acceleration factor. So this time I use the other form of equation, both the same. You can try it several times and find out which one is better working for you. So V2 in the iteration 0, which is 1 with the angle of 0, 1.6, new value of V2, and then minus previous value. So this is the new value of this is the new value after calculation. You reach to 1.004 minus 0.08 J per unit for sure. This is the voltage of bus 2 after acceleration. Then the next value we have to calculate is for bus 3. Since bus 3 is a PV bus, we have to calculate, where is it? It's here. We have to calculate the Q first. How we should calculate the Q? The Q coming in the form of V I conjugate times current. This is V I conjugate times I, correct? Since this is I, this is considered as a current. and then imaginary part minus imaginary part. So let's back to that one. Don't forget for this one, in compare with the this equation, which you ignoring the self value of y. Okay, here we ignore, see, it's from 1 to I minus 1 and I plus 1 to n. So the I is not there. We don't consider, as you can see here, also is showing by k. So for this equation, we don't consider the self value. But for the next, which is q, we must consider it from 1 to n. So the k or I must be considered, whatever it is. The self one also consider. So let me jump back to the equation. Where is it? Is here. So the q in the iteration of 1 is minus imaginary part of voltage of bus 3 conjugate. So you can see conjugate is here since it's 0, so no difference. Y31 V1, Y32 V2 accelerated, and Y33 V3. So Y31 is 20. You can find it out from this matrix 20, 40, minus 60. So uh, 20, 40, minus 60 is here. So the voltage 1.025 is here. The accelerated value replaced by here for voltage bus 2. And this is the value of V3 in the iteration 0. Okay, so this is V2 accelerated in iteration 1. Okay, and this is always the same. There is no changes. So after calculation, the value become 3.296 minus 1.1742J, okay, which we need the imaginary part, which is this value, and we have to times it by minus to remove this minus. So this is the final value we have. So after this one, we have to calculate V3. But from V3, we know the magnitude. We only need to calculate the angle, but we have to do it the same as a previous V2 or for the PV bus. So 1 over 160J, which is 1 over this value Y33. Okay. 3 is a rate of generation of this, which is 300 divided by 100, reach that value. Minus means S conjugate, correct? Minus 1.1742. So this value coming here and then become conjugate over V3 previous iteration conjugate. Again, you can see here is a minus and conjugated since there is no difference with the without conjugate. Right now, we don't consider this one anymore for this, okay? So it's Y13 V3 in the iteration, in the normal iteration, Y3 to accelerate. So 20, 40, and the value is here. The final value calculated is 1.03 minus this value. Then the angle calculated here. So this one, so this value is coming from here. What is the value given? 1.03. We don't consider the ups value or the magnitude of this equation, but must be close to 1.03. You cannot suddenly change it to 0.9, it's fully wrong, or suddenly become 1.2, again it's wrong. So the calculated value must be ups, must be something close to this one. Sometimes it's 1.0301 or 0.305 or become 1. It's something close to this value. I want to say 1.03. You cannot change it to a big value or one become 298 something. This is close to 0.3, you can see. Then the final value, we need the angle here. You just pick up the angle and using for V3 iteration 1. So V3 iteration 1 is here. We have it as iteration 1 for V3. Then you need to repeat all this equation for the second round as a second iteration. V2 in the second iteration 1 over ATJ, don't forget this is ATJ, minus 4 plus 2J, this is the load value P plus JQ, and this is the voltage, accelerated voltage in the previous iteration. You can find it here, yep, this value. And this is Y, the 2 is connected to Y21 V1 plus Y23 V3. Okay, so the one Y12 is here, V1 again is constant, nothing changed, a slack bus. Y23 still constant. V3, we use this new value. We use this new value, which is coming here. So you can see it's replaced by here. After that one, you have to accelerate again in the same procedure. And this is the accelerated value. This is the accelerated value by here for the V2. And then again, we already done with bus 2, jump to the bus 3. Again, first, we have to calculate D Q Q3 in the second iteration, which is imaginary part of 1.03 with V3 conjugate. So V3 is minus 0.266. The conjugate become positive, as you can see highlighted here. Again, Y31 V1, Y32 V2, and Y33 Y3 in the iteration 1. And then don't forget, is there an accelerate? No, there is no accelerate. Okay, so this is the new value. So this one is here, constant, constant, constant. V2 accelerate is coming from here. Let me change the color to purple, I think. Hope is so this one is coming here, and this value is coming from V3 of previous iteration. Then again, you calculate the V3 and find out the angle of V3 in the second round. Okay, you can do it by yourself. It's not a tough one. Let's jump to part B. It said, let me first clean up here. Control A. It said, part B said, if after several iterations the bus voltages converge to this value, V2 become this one and V3 become this one, determine the line flow. So, okay, how we should do that one? We should consider S12, S21, S13, S23. Okay, first you have to calculate I12, which is the current between bus 1 and 2, correct? So which is y over Z12 V2 minus V2 minus V1, yeah. So the value is this one. Then S12 is V1 I12 conjugate, and S21 become V2 I21 conjugate. This is calculate the losses of bus 1 2. So you have to add up S12 plus S21. Then for the line 1 to 3 means connected between 1 and 3, 1 over Z13 V3 minus V1, and you calculate S13 S31, and then you can find out the losses between bus 1 3, the same things, S13 plus S31, the losses of bus 1 3, and 2 3 also in the same way. So the final P loss is P loss between bus 1 2 plus P loss between bus 1 3 plus P loss between bus 2 3. This is the final P loss you can calculate by yourself. And next one, determine the flow diagram of that one. This is not an important one, but you can see how the P is going out from which way. As you can see, the P is going out from this way, and of course it's going to this way. For this one is coming, of course it's sending out to this way. I think there is some, yep, okay. This is the total three first question for load flow uh, and load flow tutorial 5. Thank you.